Okay. Good day to my talk about autoscaling your Nomad jobs. Let's first start with a little introduction about me. I went to university to become a molecular biologist, and I found out that I was actually much better at doing statistics at the 100,000 plus data points data I generated every week. Back in those days, that was big data. So I slowly descended into becoming a dev in bioinformatics. Some of my colleagues said I sold my soul to the dark side and became a dev in an operations situation, in an academic situation. When you're the dev guy or the developer, you're also the operations guy because you need to make sure your own servers run well. And at the moment, I am employed by a little hosting and consultancy company called Hot Potatoes, where I'm the CTO in The Hague here in the Netherlands. To actually start discussing Nomad autoscaling jobs, we need to first go back a bit into history and discuss how we used to deploy applications. And what we used to do is we had a bunch of servers somewhere in a server room or rack, hopefully not under your desk, but I have seen it happen. And the way to scale it was basically put a load balancer in front of it and scale by adding more and more hardware. This was possible back in those days because purchasing of new hardware was actually slow, so we could rack them slow. But that meant that if you had a product or a company or website that has cyclical visitors, think Black Friday, the Christmas rush, that you would have to have all the servers in your little server room that to fulfill your Black Friday rush. But that meant that hardware was actually doing pretty much nothing the rest of the year. So that's a huge capital expense. It's ecologically unfriendly because it's still burning electricity. So that was doable because the world was a bit slower than it's now. But now that we've all moved to the cloud, there's things can go faster. We can scale much faster. And in this cloud, there's this notion of at least the illusion of unlimited scalability. Therefore, we can do it the fast way. So you can actually spin up just in time your hardware or physical hardware, or virtual hardware in the cloud to deal with Black Friday basically on the couple of days that you need it, and then spin it down, reduce your cost, and be economically friendly. That builds up to Nomad. Nomad is the job scheduler that the awesome people at HashiCorp developed, and it's a tool to schedule pretty much any workload you can come up with. It's very good at container-based things, but you can also run Java workloads directly, or basically you can extend it. It's extended with plugins. So whatever workload you want to schedule at Nomad, you can if you write the plugin for it. There's an awesome ecosystem where people start publishing their plugins already. HashiCorp publishes as part of the documentation as well, the well-known and well-used plugins. So today I'd like to discuss and show you more about Nomad and how it would help you scale just in time for your Black Friday rush. It's actually, the talk is in continuation or built upon my personal, highly over-engineered personal website. It is a single page static HTML that runs in a container on Nomad on an AWS instance that is fully terraformed. It started as a joke, but it's at the moment it's also very useful as a learning vehicle for me to know more about all these technologies and apply them in a real world example. Albeit my website doesn't actually get that much visitors, but it's the thought head counts. So let's look at how in Nomad, you would deploy this this website. Nomad jobs are written in the HCL, the HashiCorp configuration language DSL, and it looks a bit like this. So you define a job of type, and it's my blog. I declare that it runs in my AWS environment, and it's a service. Then there's a group where you can add multiple tasks. In my case, there's only one task, the Nginx task, which is of type Docker, and it runs my blog, which it gets pulled from my my private Docker repository. And I expose port 80, like usual, and that's where my my blog will run. If you go into Nomad itself, there's it provides a nice UI for those people who are into UIs. There's also a very nice CLI tool, and in this case, you'll see there's several services running already. Most of them observability things like Prometheus, like Loki, but also my little web app. So that's that. Having said that, Nomad jobs run very well, but you basically still have one instance, a hard-coded number of instances somewhere in your cloud or your private data center. So a while back, actually introduced in Nomad 0.11, the team introduced the Nomad Autoscaler. That's when some of the community people were hired by HashiCorp and started developing the Nomad Autoscaler in-house. At the moment, it's a independently developed project, so that it has its independent release cycle, so it can quickly iterate through the feature set they want to gain or provide. And it's a very awesome tool. Every new release has new functionalities. It's you can do at the moment, it can do horizontal and vertical scaling, meaning that I can increase the number of instances I run, but I can also scale the amount of nodes, your actual Nomad platform, it can be scaled. And again, as most of the HashiCorp tools, it's a nice plugin based system, so you can write your own plugins, and the community is getting ready or is busy writing awesome plugins to, for instance, vertically scale Google Cloud or Azure. So how does it work? The autoscaler makes decisions based on checks, and a check is a combination of data queried from some metric store, it's a metric basically. It's queried from an APM. The example I'll be using later, Prometheus, and it uses a strategy, basically a number that needs to be reached, or it needs to be over, it needs to be under, and it even can use multiple checks, which you can combine into making the autoscaler make decisions for you. There's a little asterisk, little note to keep in mind. If you use multiple checks, the answer would yields you the most resources will win, and that's basically to prevent you will prevent the autoscaler from basically reducing the numbers to a point that it's no longer useful. But keep that in mind. You might see more resources running than you think, but that's a feature, not a bug. So the autoscaler can be, it's a bit meta, but the autoscaler can be deployed as a Nomad job, which is very cool. So Nomad takes care of most of the heavy lifting. It looks very similar to the blog we just deployed. My autoscaler job will run in my AWS data center, and it has a single task of type Docker, and it pulls in the official Nomad autoscaler Docker image, and then we basically pipe to it some settings. The most interesting one being that we want to use a config file, and that looks a bit like this. There needs to be at least 3 things in there you need to point to your Nomad server, which in this case actually use a Nomad variable to point it to itself. And then I'll point it to our Prometheus, in this case my APM, my data store, where we'll be querying for results. And it lives in, it also, as you shown before, it also lives in my Nomad cluster, and it is exposed as a console service, and which I'll address directly. And the target we want to do is basically reach a certain number of running instances and try and titrate to that number. As I said, the metrics that we look in today will be coming from Prometheus, which is a very cool data store. It's the relatively new kid on the block. That is a CNCF, the Cloud Native Foundation tool that came out originally out of SoundCloud, that now stores loads of metric, and it's very, very scalable. It's all cloud native and cloud ready. So we'll be using that as our APM. So what does the autoscaling bit look like? How does it work? In this case, we'll be extending our little blog job definition by adding a scaling stanza, which is the one just below in the group. I also bumping the number of running instances to 3 to see also the downscaling in a minute. The scaling, well, it's enabled, and I'm asking Nomad Autoscaler to have at least 1 instance running and a maximum of 20. And the policy is in this case, go into Prometheus and do a query, look for a traffic service, which is my ingress tool, our proxy, say, and query for the amount of open connections. So how many people are actually visiting my blog, which can be found by querying for a certain tag, which is the blog at console catalog. And the strategy is to have an average of 5 connections, and not to make Autoscaler go crazy and do up, down, up, down, up, down decisions. We say have a cooldown period of 20 seconds. So wait 20 seconds, reevaluate, and then make your decision, which basically flattens out the amount of decisions it's making and makes your platform a lot more stable. We'll be reviewing these metrics, these decisions, in another very cool open source tool called Grafana, which is the golden standard at the moment for metric dashboards. It originally started as a tool just to read graphite data, but as it's plugin based, over the years it's gained a lot of available backends which could query pretty much anything. In this case, we're going to look at Prometheus, and later on we're going to look at log data even, so coming from a tool called Loki. What does it look like? I'm showing you a sample dashboard that is available in the HashiCorp Autoscaler demo app. There's a couple of things you can see here. It shows you how much RAM we're using, how much visitors we have, and how much RAM other applications are using. But the main things we're looking at is the amount of workers running, which is the web group app count. So at the moment we're seeing 3. We're seeing 3 instances running, and we have an average of 0 connections. It's okay, because it happens. So if we actually turn on the autoscaler at this point, it actually will start making decisions. So you saw I started it with 3 instances, but I said you're allowed to go down to 1. Since we have 0 visitors, it will actually decide to just go down to that 1, to the bare minimum. It doesn't actually titrate it to 5 connections, but this is the bare minimum that it needs, so it will scale down. If you start looking at the actual output the autoscaler does, it's relatively verbose, where you can pretty much see everything that happens. So if you look at the output that I presented here, it shows you that it goes out to Prometheus, starts querying information. It works out that we have not that many visitors at the moment, so it decides that we could go down to 0, which is not something we want. Therefore, it automatically corrects itself, saying no, we could go to 0, but that's not good. So we go to the minimum that it's allowed, which is 1. So we'll have 1 instance running. And then in the last line, you see that it forces the scale down action. So we go down from 3 to 1 due to the minimum value being set to 1. So if we start applying load, which can be easily done by tools like Hay or Gatling, which is basically you provide simulated load. You see that in this case, we have the 5 connections. Actually, it's a bit more. So you see that it scaled the platform up to 6 running instances, having 5 connections each. So there's a total of 30 going on at any time. That's how the testing tool is triggered, which you can see in the light blue line. And then Nomad starts deciding, okay, we need to get an average of 5, and we have 30, so we need to have 6. And then you start seeing that it starts scaling the amount of instances. If I remove the load, the reverse action will happen. So it will work out that we don't need 6. And we'll only need the 1 because our entire load is gone. As I said, Loki, it's a very cool tool that came out of the Grafana company, which is their answer to making log storage easy, or as they say, logs, Prometheus for logs, which is a very simple tool to aggregate logs and query logs. There's other tools available, both proprietary and open source, but they're actually very hard to run in and of themselves. They become a platform you're running, whereas you don't actually want to run the additional platforms. You just want to run your own. And Loki makes it very easy. It's a single Go binary that you can run as a single process, or actually they build it very nifty so you can run it as a microservices setup where you can scale the bit of the platform of the application you want. If we add Loki to the mix, so we can do 2 things. We can directly send our logs into Loki by adding a Docker plugin, which you can install very easily on the command line using Docker plugin install, and then the official Grafana Loki Docker driver. And then you add a little stanza to your jobs, a logging stanza that tells Nomad that it shouldn't store the logs for you, but it should directly send them to Loki. In this case, it's also something that runs in my Nomad, so I push it directly to the console servers. That's where all my logging goes. So you'll no longer see any logging in Nomad, but it will all be stored centrally. And the other option is, if you don't want to have it directly push, you can add a Promtail sidecar. Promtail is the CLI tool for Loki, and since a while now, Nomad has the ability to configure sidecars, basically a container that can act on the original container. In this case, Promtail, we tell it to pre-start and act as a sidecar and just pull in the original container from Grafana and point it to a config file. For those of us that know Prometheus, the Promtail configuration will look very familiar, and that's because they use the same configuration type. So in this case, I'll just say look in the Nomad allocation directory for log files and do some matching to get the actual variables out. This is quite long form, and that's because it's an example where the logs also still go to Nomad, but you could switch this to a JSON-based format, and then it's a lot easier to read. How do I correlate my logs to my metrics? And that's in Grafana. You can do those by annotations. So in this case, we actually correlate the events that the Nomad autoscaler pushes out, and we can correlate them by the metrics and the graphs we see by adding the annotations in Grafana. It's very simple. We basically tell Grafana and a little annotation. We give it a sensible name of scaling actions. We pull it in from Loki, and what it does, it goes into Loki and it queries for things that have a tag of task is autoscaler, and it smells like a scaling target. So basically find words, scaling targets in my log. And then we have the little blue vertical lines that you see here in the graph. We've seen them before, but I haven't explained them. But now you can see that every vertical blue line is actually a decision made by Nomad, and by hovering over it, you see that the output of the autoscaler decision. So here it's we're hovering over the downscale event. So it says we have 6, we want to go down to 1, actually 0, but we want to stay at 1. This way you can very nicely correlate the actual events happening and the metrics. You can try this all yourself. I mentioned this before. It's all in the Autoscaler Vagrant demo, where you can try all the things we've seen before. So in autoscaling, upscaling, downscaling, the correlation of the logs. And this does adding, this whole story describes moving more instances into your platform, but eventually your platform is limited by the original scale. So we still can't deal with the thundering herd on Black Friday crowd. So what Nomad, the autoscaling team, or the Nomad team did was build a plugin that actually can grow your platform for you. So based again on metrics, it can actually scale the amount of Nomad workers nodes you have. And so we need to tweak our configuration a little bit by changing the target to, in my case, I run on AWS, so I want to tweak my AWS settings of the target's called AWS ASG, so scaling groups. And I want to make a decision based on CPU, which we'll discuss in a minute. So we need to also add a scaling policy, which I'm showing here. Basically that we look up how much CPU is used, and if that goes over a limit, in this case my target is 70. So if my CPU is doing a lot of work for a significant amount of time, in this case 2 minutes, then start building out in my platform, not just the amount of workers I have, the amount of instances of my blog I have, but actually start building out the nodes that my blog instance can run on. And then we add a little bit of configuration, in this case, node drain deadline for 5 minutes. So we need to be able to get my nodes in and out pretty quickly, and otherwise start making decisions that stuff won't be ready. So this is very cool. We can now add more instances. We can add more nodes. So in theory, we can grow our platform to the size of AWS. So as long as they can add servers, we can grow into them, which is a very cool and very satisfying way of dealing with your growing platform. And that's so there's another try it yourself in the same repository that I mentioned before, and then you can actually grow and show. We can do tests with Azure and AWS at the moment. So moving in the cloud, I hopefully approve now that you can grow into any direction you want with very easy setup using HashiCorp Nomad, which to me is the easiest work scheduler that is around. So please try and be happy. So thank you. My name is Bram. You can reach me by email or in the Twitter sphere. And if you want to recheck or re-look at my slide deck, they're available on SlideShare and probably on the HashiCorp resource website by now.